The last thing I want to say about exceptions is to point out a little issue you're likely to run into at some point when using real library code. So occasionally, you'll write some innocent little method like this. I have a main method that calls the goalGate method of some eagle class, but when I try and compile it, it yells at me and it says, must be caught or declared to be thrown, some kind of unreported exception. So what we're going to do in the next few minutes is pick apart what's happening here exactly. It just seems strange here that I'm just trying to compile my code and it's saying something about unreported exceptions. So the basic idea that underlies all of what we're about to talk about is that some errors, some exceptions rather, are considered so disgusting by the compiler that you have to handle them in some way. And there's a specific thing known as the catch or specify requirement that we're going to describe in a moment. So these special exceptions, the ones the compiler really hates, are called checked exceptions. I think a better name for them would be must be checked exceptions for reasons that'll become clear soon, but well, we'll get there in a moment. So all of our examples so far have been so-called unchecked exceptions. However, as we just saw, it seems like there's something else. There's also these things known as checked exceptions, and these the compiler requires that they be caught or specified, and I'll say what specified is in a moment. And the basic philosophy behind this is that the Java compiler wants to prevent any situation where there's an avoidable crash that could have been handled. Okay? And we'll philosophize at the end of this little section about what exactly that means. So let's actually consider here a piece of code that we write everything ourselves, right? So here we are relying on some external library. Who knows what's happening? In this example, I'm making a class called Eagle, which has a goalGate method. If today is Thursday, it throws a new IO exception, which is just something I dug out of the libraries. So if I try and compile Eagle as it's written right here, a funny thing happens. We get unreported exception, IO exception, must be caught or declared to be thrown. Even compilation fails. Now contrast that with this alternate situation in unchecked exception demo. In this case, it's almost the exact same idea, right? If today's Thursday, now we'll throw a new runtime exception. This code, if I try to compile it, it's perfectly fine, does not matter. And if I try and run it, well, it'll crash, of course, if it happens to be Thursday, and say, haha, got you. It's weird joke, Who knows how their sense of humor works. So this program right here, the only difference between them, the only meaningful difference is that this has a runtime exception and this has an IO exception. So what's happening? What's special about this? Why does the compiler allow one and not the other? It's actually a pretty simple rule. Anything here in blue that is error, runtime exception, or any of their subtypes, they're all throwables, these are considered unchecked. In other words, they don't need to be checked. If your code throws them, the compiler will say that's fine. But if at any point there's any possibility of any of these red classes, these are all the checked examples, if any of those have any possibility whatsoever of occurring, you must either catch or specify those exceptions. Otherwise, the compiler will not allow that code to be compiled. So let's see a little compare and contrast here. With our unchecked exception demo, because runtime exception is on the blue side, it does not care. Java says that's fine. I know it's a little weird for you to be doing it, but I'm going to allow it. But over here, because there's the possibility of, a red exception, then the compiler will yell at you and say, why didn't you catch or specify? That's in the rules. Okay? Well, maybe you didn't, but now you're learning. So let's see what that means. Okay? How can we actually handle one of these red exceptions? What is it that we need to do? Well, the first thing we can do is just use a catch statement, as we saw before. And in this case, in my Eagle class, in goalGate, I could say, if today equals Thursday, throw a new exception. And then I can have a catch block here, so that if it happens to be Thursday, that exception is captured and it can't escape. So if we look at this code, the compiler says, is there any chance this exception that I absolutely hate that's over here, is there any chance it could get out? No, it couldn't get out because there's a catch here. And so in this case, the compiler allows it. We have caught this checked exception. Now I'll mention just briefly, because I ought to, that because an IO exception is an exception, it's a subtype of exception, right? So notice IO exception, exception. This catch will actually catch IO exception. However, if I did something like MIDI unavailable exception, it would not work because this catch block does not actually capture IO exceptions. They're cousins. They're not a parent. This is not a parent of IO exception. And so if we tried to compile the code like this, it wouldn't work, just as an aside. Now, the alternate possibility, other than catching, is to do something known as specifying. So what is specifying? Well, to do that, we simply take our method and we mark it with an extra new keyword we've never used before called throws. And this means I might, maybe by the way, throw an IO exception. So it's a declaration to the world that Goalgate has the property that it might throw IO exception. It doesn't always, it just has to be Thursday, but it may. And so that way we know. So if we try to compile eagle with this method signature as opposed to this method signature, it'll work perfectly fine even without a catch. So no catch, you just put throws IO exception, it'll compile just fine. So basically the philosophy there actually is that we're deferring to someone else. We're warning the world that I'm a method that's dangerous. When you Goalgate, there might be an IO exception and you need to handle it. So here's an interesting note, which is that if a method uses a dangerous method, that is, if it uses a method that might throw a checked exception, it becomes dangerous itself. So if we look at Goalgate here, when we say throw new IO exception, if in the main method we call eagle.goalgate, this is why when we tried to compile our code, we get unreported exception IO exception, must be caught or declared to be thrown. Because this method right here throws IO exception, main also, obviously, since this can throw an IO exception, so can main. And so in this case, we're not handling it. There's an old Nietzsche quote, which I think summarizes it nicely. He who fights with monsters should look to it that he himself does not become a monster. And when you gaze long into an abyss, the abyss also gazes into you. So how do we handle this? How do we deal with the fact that eagle Goalgate might throw an IO exception? Well, we have a rule for that. We can either catch or specify. So here's my code up top. One possibility is in main, we can catch it. We can try to Goalgate. In this case, I've imported the method from eagle already, so it's not actually saying eagle.Goalgate, sorry. And then we catch that exception. And in that case, we've averted the crisis. This will compile just fine. And in this case, we're keeping the exception from getting out. We're containing all that abyssal energy. And you can do this as long as you can handle the problem. So in this case, we handled the problem by just saying, no problem at all. But sometimes you actually want to do something, like maybe extend the antenna or whatever it is. The alternate possibility is to make main itself to declare that main is dangerous. So main might throw IO exception, and in that case, this will also work. The difference is that on the left-hand side, you provide the remedy, and on the right-hand side, someone else has to provide the remedy. So here, you specify that you're dangerous, and someone else in this case should handle it. So the last thing I want to say about exceptions, then we'll move on to other things, is that the reason that Java does this, right? So you might ask the question, why does Java not require that every exception be caught? Maybe ponder that for a moment. But I mean, the answer is simply that these are exceptions you can't predict in advance, and if they do happen, what are you going to do about it? Like if you get index out of bounds exception, it's likely there's nothing you can do. But by contrast, if a file is not found, you can maybe ask the user to go get you the file or something. And so what's interesting about these exceptions, these are things for which a remedy conceivably exists. That's why Java requires you to handle them if possible. Remember that Java is largely about making sure that you don't shoot yourself in the foot. And so here, basically, if we look at in this, this is the API of a class called FileWriter, we can see that each of the methods, there's actually part of the declaration. It's warning you that if you create a FileWriter, it might throw an IO exception. And so that means that if you're using a file writer, you need to keep that in mind. So that way, if you try to write to a file and you find, oops, writing to the file didn't work, then you can do something, whatever it is that you think is necessary. Okay. That's it for exceptions. And so we'll move on to a new topic. There's more to know about exceptions than that, but that's the most important stuff we need to know for 61B.